Hi there. So we're going to work through some problems on particle motion, hopefully to kind of give you some ideas that how you're doing, where you need to practice. If you haven't seen my video on the 5 principles of particle motion, I believe it is a really must see. So if we get into some of these problems, you're like, I haven't learned this before. Go back and I'll link it in the comments below so that you can watch it. It's really a good one to kind of keep handy and go back and review so that you have all of those details. That being said, let's go ahead and dive in. So for this one, we're being told that a particle moves along the x-axis and we're given the position function, and we'll use this for questions number 1 through 4. So question number 1, what is p prime? What is p double prime at 2, and evaluate which each response. So p double prime, let's go ahead and find p prime of t first. We'll need to use chain rule. That's 2e to the 2t minus 5. And just for, simplicity, let's go ahead and find second derivative. That'll be 4e to the 2t. Now, if we want to find that at 2, then p prime at 2 would be 2e to the 4th minus 5. And let's do p double prime at 2. That would be 4e to the 4th. Okay. And now what do these represent? This is the velocity at t equals 2. And the second derivative is the acceleration at t equals 2. Okay. Now look at both of these. Based on these values, what can be concluded about the speed of the particle? Well, both of these values are going to come out to be positive. Since they are not just positive, but since velocity and acceleration share the same sign, the speed is increasing because v of 2 and a of 2 have the same sign. Okay. And again, if that's one, you're like, I don't know that. I didn't know that rule. Go back and look at the 5 commandments of particle motion. Really, really makes sense. Okay. Look at number 3 then. On what intervals is the particle moving to the left? Now remember, friends, moving to the left, that's where velocity is negative. To the right, velocity is positive. So the first thing we have to decide is, where is the velocity? That's the first derivative, equal to 0. So I've got 0 equals 2e to the 2t minus 5. Move your 5, divide by 2. And then go ahead and take the log of both sides. So you get that t is 1/2 ln of 5/2. Now I'm going to let you put that in your calculator. I got a value of 0.458. Okay. Now I'm going to put that on my number line. And I'm going to test both sides of the number line. So I'm going to do a value of 0. I'm going to test the velocity at 0. My velocity at 0 would be e to the 0, which is 1, times 2 is 2. 2 minus 5 is negative. And I forgot to label my number line. Let me make sure and do that. Then I'm going to test t equals 3. Make up a number, any number over there. So I've got e to the 6th times 2 minus 5. That's going to be positive. Check those on your calculator if you need to. So let's see, the particle moves left on the interval 0 to 0.458. Be real careful that you don't say from negative infinity. Why? Because we were given a domain. Okay, then you've got the particle moves right, and that's from 0.458, and you can say that is to positive infinity. Okay, now remember it says justify your answer, but as long as we label our number line, we're going to be okay with that. And the last question for this part is, does the particle change directions? And the answer is yes, because the velocity changed signs, we are going to be changing directions. Yes, because the velocity changes signs at t equals 0.458. All right, let's go ahead and look at number 5 then. We are given the velocity graph and we're asked about the movement along the x-axis and the acceleration. So meaning, is it moving left or right? This is the velocity graph. So when we look at this as terms of velocity, we look at the y values. The y values here are less than 0. So that means from 0 to 2, on the interval from 0 to 2, the object moves to the left because the velocity is negative. Remember, we're looking at the y values. On t is greater than 2, the object moves right. And that's because the velocity is positive. Okay, now let's turn our attention to the acceleration. When we're looking at the velocity graph and we ask about the acceleration, we're talking about the slopes. So, since the velocity is increasing, and it is, we can see that from the graph, on t is greater than 0, the acceleration is positive. So see how I can look at the velocity graph and I can tell things about the position and I can tell things about the acceleration. That's why more times than not, the velocity graph is the graph that is given on the AP exam because we can ask you questions about both ways, ask you about the position, ask you about the acceleration. All right, let's keep going. We're doing great. The next one, let's see. We have the position defined as this function. And we want to know if the speed is increasing or decreasing when t equals 2.5. Now remember, speed is increasing when velocity and acceleration have the same sign. Speed is decreasing when they have different signs. So let's begin by finding the velocity. That would be the derivative. So we get 3t squared minus 18t plus 24. And we can find the acceleration, which would be the derivative of the velocity, and that would be 6t minus 18. Now we want these at 2.5. Now be sure and use your calculator because you're squaring a decimal. And I'm going to let you put that in your calculator. Let's see, what value did I get? Let's see, I got negative 2.25. Again, I'll let you put that in your calculator. And then I'm going to find the acceleration at 2.5. So 6 times 2.5 is going to give me 15. 15 minus 18 is -3. So notice velocity and acceleration are both negative. So since velocity and acceleration are negative, the speed is increasing. So remember, it's not that they both are positive, it's that they share the same sign. So that's important there. Okay, let's look then at number 7 through 9. We'll use the position of the particle. We'll use the function p of t here. And we're looking for the average velocity. Now remember, average, putting that word average in front of it means, hey, do the slope the algebra way. So to find the average velocity, we're going to do the position at 3 minus the position at 1 over 3 minus 1. Now put in 3. Let's see, 2 times 3 is 6. 6 minus 3 is 3. And then e to the -1. Minus, and then put in 1. 2 times 1 is 1. I'm sorry, 2 times 1 is 2. Minus 3 is -1. So I'm going to make that a positive. E to the 1. And that's over 2. Now take a minute and put that in your calculator. You should get 1.911. I normally would want to put units on it. However, there were no units given in this problem, so I'm not going to stress about it. Definitely watch how you put that in your calculator. Okay, now let's find an equation for the velocity. So we're going to take the derivative. Got a little product rule going on here. So I've got the first times the derivative of the second, which is e to the 2 minus t times -1. Now the derivative of the 2 minus t is where I get that -1 from, plus the second times the derivative of the first, which would be 2. Now let's go ahead and distribute here. Well, friends, I see that they have an e to the 2 minus t. So let's go ahead and pull that out. If I pull it out of here, then I'm left with 2t minus 3. Except I've got a -1 to worry about. So let's make that a -2t plus 3. And then if I pull it out of here, I've got a 2. So that gives me e to the 2 minus t times -2t plus 5. There's my equation for the velocity. Okay, one last part for this position equation, and that is we want to know when will the velocity equal 0. So let's set that equal to 0. Now I want you to remember your your exponentials can never equal 0. So you think about them, they have this horizontal asymptote at 0, and that's why they can never equal 0. So even when you try to set it equal to 0, you're not going to find a place where it equals 0. So you set the parentheses equal to 0, and you can see then that I get t equals 5/2. And that's where the velocity would equal 0. Okay, friends, just a few more. We're almost there. Now, this one is a particle motion question that came from 2003. It is a partial because there was a part C that we had to deal with. But we're not ready for that yet. It doesn't have anything to do with derivatives, but we're going to go forward. Notice we were given the velocity equation here, and we're asked to find the acceleration. So let us do that. Now, something I want you to notice is that this was question number 2 on the year it was given. And something you need to know about AP exams is questions 1, 2, and 3 are with your calculator. And then your calculator goes away And you are then asked to do 4, 5, and 6 without your calculator. So I'm going to switch our view so you can see my calculator because I'm going to use the calculator to find the derivative here. And if you haven't seen my videos on how to do this, we'll walk through it this time. I put the equation in y1. You'll have to use x's instead of t's, but that's totally okay. Now, earlier today, I was doing some trig, and I want to make sure that I'm in radian mode. Good, I am. It's right there. But I was using my calculator for some trig, and I want to make sure I didn't leave it in degree mode. All right, so I've got my equation for the velocity, and I'm just going to graph it. It's going to be crazy. I don't really need the graph, but I need it to go ahead and process the graph so that I can use the next feature, which I'm going to do the derivative feature. So I'm doing second trace, and let's do this acceleration at 2. So I'm going to do second trace, and I'm going to choose option number 6 to find the derivative. And then it doesn't ask you for anything, but you just need to type in the value you want, which is 2. And look there, it gives you the derivative, 1.588. Now, we're also then asked for, is the speed of the particle increasing at 2? Now remember, speed is increasing when velocity and acceleration have the same sign. So I have the acceleration. Now I need the velocity. I can do all of that on my calculator by using second trace. Now I want option 1. And I plug in the value of 2. This is going to tell me the velocity at 2, and I got a negative. So is the speed increasing? No, the speed is not increasing at t equals 2 because acceleration at 2 is positive and velocity at 2 is negative. All right, now the next question asks me, find all the times between 0 and 3 when the particle changes direction. So remember, particle changes direction when the velocity changes signs. Now looking at my graph here below, I've got a lot of graph. I only need to look at between 0 and 3. So let's go to your calculator and use your window. You can set your x min to be 0 and set your x max to be 3. Then when you graph, you're only going to see this interval. And I think that's very valuable. I'm wondering if it changes right here. So I'm going to adjust my y min and max. I'm going to bring them in a little bit because they're a little far out. So I'm going to do it at -2 and 2. I'm going to get a little closer, and it doesn't look like it does cross anywhere in here. But it's going to cross over here, and I need to find that value. And the way I do that in my calculator is to do second trace 0, option number 2. Now my cursor is down here somewhere. See the coordinates for it? It's down here. So I'm going to go ahead and press enter, but then I'm going to use my right arrow. I've got to get to the right of where it crosses the x-axis. So use your right arrow until there's my cursor. Here it comes. Here it goes. Now you can press enter and enter one more time. And there is your value you were looking for. So at t equals 2.507, the object or the particle changes direction because the velocity changes signs. And that's your justification. So I hope that helps with these problems. I think they're really good to work through the particle motion. Like I said, Almost every year, one of the free response is going to be a particle motion, and you can really hit it out of the park if you really know those five commandments of particle motion and you've practiced, seen a lot of the styles of questions. So, as always, feel free to leave a comment below if there's anything I can help with or you'd like to see a video of. Don't forget to like and subscribe. That way, you get a notification every time a new video is posted. Bye for now.